the next step in our journey is to find out whether the nature of surfaces, it has any impact on the friction acting over the connected bodies, or you can say the body in contact with a surface. So let us find this out by carrying a simple activity. Here we have a brick which is placed on a table. And now what we are going to do is, we are going to attach this brick to a spring balance. And just try pulling this brick with the use of the spring balance. So what do you think happens? Are we able to move the brick? Now that the brick is not that heavy and we are applying a force on it, so as one would expect, the brick it begins to move. When the brick just begins to move, we get an estimate of the force of sliding friction between the contact surface of the brick and the table. Like in this case, the reading of my spring balance, it comes out to be 600 grams, which is approximately equal to 6 newtons. Now we cover the brick with a piece of polythene and repeat the same activity. So what do you think now? Will there be any change in the reading of the spring balance? And is it going to be more than the previous case or less than it? Well, in fact, some of you may even be thinking, so why more or less? It is the same brick, so the amount of force which is required to move it, it will still be the same as was in the earlier case. Let's find it out now. So here we see that the reading of the spring balance, it comes out to be 450 grams, which is approximately equal to 4.5 newtons. And as a matter of fact, this is lesser than the previous one, when the brick it was pulled without being covered with the polythene. Thus, less force is required to move the brick when it is covered with the polythene bag than when it is not covered with it. And consequently, it had a rougher surface area. This shows that rough surfaces, they offer more friction, while smooth surfaces, they offer less friction. Thus, we may conclude that the force of friction, it depends on the nature of surfaces in contact.